Memoization is an optimization technique used in many programming languages to reduce the number of redundant, expensive function calls. This is done by caching the return value of a function based on its inputs. In this post, we'll create a suboptimal, but hopefully educationally informative, JavaScript memoizer. First, let's create an expensive function to memoize. The function we're going to create today is a function that will square a number you give it. But instead of using a reasonably efficient way of doing it, we are going to use a super inefficient way. So we'll call this const inefficient square, and that will take a number as an argument. And we are going to create a total, and we are going to create a couple loops. So for let I equals 0, I is less than num, and then we will increment I. And then we'll create another loop. Let j equals 0, j is less than num, increment j. And then we'll increment our total. And we'll return our total from this function. And great, that's a very inefficient way to square a number. So as a baseline, we can run this function with the same input and see that no matter how many times we run it with the same input, we are going to take quite a while. So let's create a start time. And we'll run our function. And let's just square the number of 40,000. That sounds pretty high. That sounds like it'll take a moment. And then we'll console log the new time. So we'll say new date minus our start date. And that'll give us how much time it takes approximately in milliseconds. Let's run this. Okay, and so this takes about 1,300 milliseconds, which is quite a bit of time. We can copy this and paste it below. And just to demonstrate that we are going to have the same input, and still, when we run it a second time, it's going to take approximately the same amount of time. So we're not doing any sort of caching on our inputs here. And sure enough, we take the same amount of time to do it twice. So now we're going to go to the beginning of our file and let's create a memoizer. So what we know about our memoizer is that it's got to take a function and then it has to return a function. How we're going to make it so that it remembers values is that we are going to create a cache. So our cache is going to be for our results. We'll say const results equals, for now it'll just be an empty object. This function will take any number of arguments. As we don't know what the user might be trying to memoize, we need to be open to any number of arguments. We are going to create a key for our cache. This, by the way, is the most suboptimal part of our current implementation. We will say const args key equals json.stringify our arguments. And then what we're going to do is only execute our function if we do not have a cached version of that call. So only execute function if no cache val. In code, we say if the results object does not have anything in the args key position, we will actually set that. By saying results args key equals func called on our arguments. Finally, we can just go ahead and return results at args key. And that's it. So now what we can do is, since our memoize function takes a function and returns a function, we can wrap our inefficient square function in memoize, and we can test this out. We still have below our code that will demonstrate whether we are doing the second call to inefficient square any faster. So we run this, and we can see the first time around, we take 1270 milliseconds, and the second time around, it takes no time at all because we're pulling a cached value. So one more note, as I mentioned before, this is suboptimal, and that's mostly because of this JSON stringify being used as our args key. I wouldn't recommend using this in production because the biggest problem with JSON stringify is that it doesn't serialize certain inputs like functions and symbols and basically anything you wouldn't find in a JSON string. So be very careful if you actually try to implement your own Memoize function. There are plenty of good ones out there from third parties that are well maintained and well vetted. So this is a great learning exercise, but definitely wouldn't recommend using it in production.